Hey everybody, welcome to Bill Sky, the C++ guy. And today we're going to talk about random numbers. Why talk about random numbers? Well, random numbers are extremely useful in testing. Whenever you test a C or a C++ program, you may not want to type in every single number or piece of data that you need to test your program. And random numbers are unbelievably important. There is a problem though with randomness is that for most programmers where you're testing your code with different numbers and you want to make sure it runs with all those different numbers, that might be okay for what we've got. But right now, random number generation is a real problem in computer science. And really, I shouldn't say a problem, it's more of a challenge. How do you make something really random? Even the random number generator inside the CPU is not really random. And we're going to see some examples of that in the code we're going to do today. If you're interested in random numbers, there's actually a project going on in San Francisco, which is the Cloudflare random number project. And what they're using is they're using lava lamps, and they've got a whole bunch of lava lamps set up in the lobby. I've actually seen this, and they've got all these digital video recorders or digital cameras, video cameras, pointed at each lava lamp. And as the lava or as the wax melts and moves up and moves down, and the number of blobs that are moving up or moving down in each lamp, it helps to generate a random number. And they actually sell this service where you can get really, really, really random numbers, or what look like random numbers. However, using quantum physics and things like that, if you know the state of each lava lamp, you know the state of each of the material inside of each lava lamp, if you know the state of the amount of voltage and the heat, you could actually calculate what the random number might be. But it would be unbelievably difficult. I don't even think quantum computers could do it. I don't know that for a fact, but it would be so difficult to figure that out. You'd have to know the quantum state of every atom to be able to do that. But it doesn't mean it's not possible. It just means that right now it's not possible. So using these lava lamps, they've come up with a pretty great solution on how to get random numbers. Also, random numbers are used a lot in encryption and other things that have to do with security. So every time you use you log into an HTTPS site, or you SSH into a server, you're using random numbers, specifically prime numbers. And that's a completely different discussion to have. So what we're going to do is we're going to create some code and generate random numbers, and you're going to see the benefit of it. So let's get to coding. Okay, so I've got Windows 11 up here and running, and I'm going to use Eclipse just because it seems to be the most stable for me. And now the font looks kind of bad, so let's fix the font up. I'm going to go up to Window Preferences. I'm going to go to General, Appearance, Colors and Fonts. I'm going to go to C and C++. Let's go to Editor and then C++ Editor Fonts and click Edit. And I'm going to go ahead and make that 14. And so that should be more readable for you. Okay. So let's close all these other. This is a brand new project I just set up just for random numbers. Okay, so one thing we're going to need is, and I'll explain why, we're going to need to pound include ctime. And I'm going to leave the using namespace std there just because it's going to make my coding a little bit easier. I will be producing a video on what namespaces are all about, so wait for that. And I'm going to put my closing, just so I know that my program didn't die. Okay, so what we want to do is we want to create our first random number. So I'm going to go ahead and I'm going to just say, let's just create a variable. Let's go up here and create a variable called int random int1. Just make it equal to 0. And then I'm going to use the rand function. So I'm going to say random int1 equals rand, and that's it. So let's go ahead and save and build that. It says unused variable, that's fine. And then let's go ahead and run it. Now the first time I run it again, it's going to ask me if it's a Fortran or C++. I'm going to click C++. And oh, nope, we actually have a problem here. Let's see what we got. So I'm going to say rand percent. It looks like we might not have, it may not know. Oh, I think I typed it wrong. Random. I put an N there instead of an M. So let's go ahead and save. See, I didn't look at my messages, so I'm going to get myself in trouble. Okay, there we go. So let's go ahead and run it. Okay, now we created the random number, but we didn't print it. So let's see out it. Or count it, as I like to say, which irritates people to no end. And let's run it. Okay, so we've got the number 41. Let's run this again. 41, 41, 41. How in the world could this be a random number if every time I run the program it's 41? Some people might say, well, maybe it's running the same code. Well, let's go ahead and do it again in our program and generate two random numbers. Okay, 41, 18, 467. Seems pretty random, but I'm going to run it again. 41, 18, 467. It never changes every time you run your program. Now, the next day it might change, but right now it's not changing. So you don't want to create a hash key that everybody that logs into your website gets the same hash key. That wouldn't be secure. So there's a problem here with randomness. And it's pretty obvious what the problem is. So what we're going to need is we're going to need the seed time, and what we're going to need to do is we're going to need to seed the random number generator. And what that means is that we give the random number generator a number that it starts with. Now, I'm not really sure what the CPU or the rand function uses as the seed if you don't specify it, but it seems like it's the same thing because we get the same two numbers every time in this case. So we need to seed it. And what I'm going to do is to seed the random number generator, I'm just going to say srand, and I could put a number in there if I want. I could just say 15. Let's save and build that. And let's run it. Okay, so the number is different. Instead of it being 41, 18, 657 or whatever that was, it's now 87, 5, 105. Let's run it again. Now it's the same thing again, but it's a different number than was default. So instead of putting 15, what is something that changes constantly? I mean, think about it. What is a number that changes all the time? Well, the time. The time changes all the time. So what I'm going to do is I'm going to, and this is why we use ctime, I'm going to specify time. There's a function called time. I'm going to send it the number 0, and that basically means return the time right now. Now, if you wonder what that's doing, I could go ahead and just say cow time 0, and then we could actually see the number. So let's go ahead and save and build that and run it. Okay, so there's the time. Now, I believe that's the number of seconds from January 1st, 1970. That is an epoch. That is a number that most time calculations begin with. And it might be because that was the first time that we actually had time clocks, times inside of computers, clocks. Now, when I got my first computer, I had to type in the date and time every time I booted it, the TRS-80 Model 1. Even the Sinclair kit computer that I built, I had to put that in every time. There was no time clock on the motherboard. But today we do, and they all seem to start at January 1st, 1970. So there's the time. Now, that time in seconds is sent to the seeder, the random number seed generator, and so now we have 2144. Let's run this again. Oh, now we got 2317. Run it again. So you can see that the numbers are changing. But also notice that the first number always seems to be 4 digits. So that has something to do with the fact that I'm using the time, a specific time, or the way that the random number generator is set up. So you're beginning to see a problem with random numbers. If you're really looking for a truly random number, this first number is not really truly random because it always starts with 2300, or in this case 2400 now. Notice it's going up as time moves on, and so this could be an issue. This could be a real problem. That's why random numbers are such a problem in computer science, or a challenge, I should say, in computer science. So let's go ahead and delete that C out, and let's go ahead and delete the second one there. So I'm also going to create. Let's create a for loop. And we're just going to create a whole bunch of random numbers. And this is something that you might actually do in your program, that you generate a bunch of random numbers to save into a file or something. Or instead of having the user type them in every time, you just do this. So I'm going to go ahead and save and build this and run it. Okay, so let's take a look at the data that comes out. So the first number is 2588, the second number is 942. Let's take a look at it again. Okay, so you're noticing that the first number is not too far away from the first number on the previous run, but the second number, I think it was 927, it's now 21393. I'm going to run it again. It's now back to 8554. I'm looking at the second number, run it again. It's now to 29528, run it again. So you can see the second number is more random than the first number. I mean, the first number is random, but it is definitely calculated based on the time. So there's something funky about that. So you might want to do something like this. Grab that first one that's generated from the program running. And let's take a look. Now the first number might be a lot different. Let's see. Yep, so you can see that the first number is now changing quite a bit. Now these are just big integers, right? What if I wanted to say that I want an integer that is no bigger than 100? So what I could do is, instead of saying just the random function, I could say modulus 100. Now this means that every number that it generates, it'll generate a number that it'll divide it by 100 and it'll take that remainder. And so the number will be anywhere from 0 to 99 every time. Let's go ahead and test that. So that's going to limit the size of your random number. And so you can see the numbers have changed quite a bit. Now they're between 0 and 99. You're never going to see a negative number. You're going to never see a 2000 number, because that's one of the purposes of modulus, is to be able to cut down on the size of the data that you're using. Okay, so let's take a look at, well, what if you want to be able to get a minimum? Now the minimum will always be 0 in this case, right? Because the random number is evenly divisible by 100. So how could you actually do this where you can also specify a minimum value that you want? Well, what I'm going to do is I'm going to copy some code here that I've got, and I'm going to, because I don't want to have to type it all in. Okay. And there's a couple of things that this code has. This code has a minimum random value constant. So let's go ahead and create that. I'm going to say const int min random value. And let's say that's equal to 100. Let's say the minimum random value we want is 100. Then we're going to have a maximum random value. So let's go ahead and copy that up here. Let's go ahead and create it. So let's say the maximum is 1,000. Let's say that's the maximum we want. All right, so I think this might run. Let's see. Yep, it looks like it might run. So let's go ahead and build it, or it might compile. Okay, so let's go ahead and run this code, and then we'll talk about it. Okay, so I said the minimum random number should be 100, and the maximum should be 1,000. And if when we run this, you can see that we got 570. Nothing goes past 1,000, and nothing goes below 100. Let's run it again. All right, that's looking pretty good, right? Keep running it. So you might get a situation where the maximum might be 999, or the number might be 999, and the minimum will be 100. But that's how you do it, to get a minimum and then a maximum. Now, how does this code work? It's a very simple little equation. I generate a random number, and I add the minimum random number value to it, because that's the minimum. What if the random number produces a 0, right? Well, I want to add that minimum, because I don't want it to be 0. I want the minimum to be 100. And then what I do is I take that and I modulate it by the maximum random value minus the minimum random value, because we don't want anything to go above the maximum random value. And then that gives us our random number. All right, great. So that's how you get a minimum and a maximum random number. Okay, so how would you calculate, what if you wanted to create a signed random number? Right now, this is just between 100 and 1,000. What if you wanted to randomly have a negative or a positive number? Well, what you could do is you could say, I don't know, let's create a random number 2. So I'm going to create a random n2. And what I'm going to do here is I'm going to say random n2 is equal to rand. And let's give it a modular of, I don't know, 100. And let's type this in right. And I'm going to say if random n2 is less than 50, then I'm going to say random n1 times equals -1. So we're going to make it negative if it's less than 50. Else we're going to do nothing. I'm just going to go ahead and leave it positive. So we're actually getting a random number. Now you could make this anything, right? You can make it modulus 10, but then check if it's less than 50. So we're just generating a random number again, putting it in random n2, and then if it's less than 50, we're going to go ahead and make it -1, or multiply it by -1 to make it negative. So let's see how that works. All right, so one thing you might want to look at is we've got 1, 2, 3, 4 negative numbers, but we've got 6 positive numbers. Let's run it again. We've got 5 negative numbers and 5 positive numbers. Cool, let's run it again. Oh, this time we've got 2 negative numbers, which means we've got 8 positive numbers. So that's a pretty random way of doing it. And you could probably do it all in one line of code, but oh, this one, it looks like we've got 7 negative numbers and 2 positive numbers. So it's really giving us what looks like a random group of integers, positive and negative integers. Okay, what if we want to create random floating point numbers? Well, let's go ahead and try that out. So I'm going to create another loop here. Let's just do 10 more. So everything we've been doing so far is floating point. So what I'm going to do now is I want to create everything we've been doing up till now is integer. Let's go ahead and create floating points. So what I'm going to do is I'm going to say this. I'm going to say random int1 equals rand. And let's say we want our floating point number to be less than 100. So we're going to say modulus 100. And we're going to do it again, except this time we're going to put in random int2 and make that %100. And then what I'm going to do is I'm going to create another variable up here. I'm going to say double, random double. Well, let's initialize it to 0. Why not? Now, why are we doing this? Why do we have to do something special for floating point? Well, because modulus does not produce floating point numbers. It only produces integers. So we have to do something special here. So what I'm going to do is I'm going to say, hey, random double, you're equal to random int1 plus random, some of you may already got this, int2 divided by 100. And why am I doing that? Because I'm taking the second random number, dividing it by 100 to move that decimal place over to the left 2, and then we're going to add it to there. Okay, so we're going to say cout your random float is random double. All right, let's see how this works out. I'm going to run it. All right, let's see what we get. There we go. So your random float is 12.53, 6622, and they're between 0 and 100 on both the whole portion as well as the fractional portion. That's pretty cool, right? So you can also do the same thing as we did up here for integers. And to do this for floating point, I'm going to go up here and create another random integer. This time I'm going to call random integer 3. I'm going to go ahead and copy this code, put it right here. Instead of random 2, make it 3, and change that to random double. And let's make it negative 1.0. And let's see what we get now. All right, we've got both positive and negative random numbers. Okay, well, what about random strings? What if you would like to create a random set of characters? That's kind of an interesting idea, right? Well, the first thing we need to do is we need to take a look at the ASCII table, because the rand function doesn't return any kind of characters, it only returns integers. So let's do this. So let's take a look at the ASCII table. I think it's ASCIItable.com. And let's take a look at what characters are, what the alphabetic characters are. Well, the alphabetic characters starting at capital A, so it goes capital A to capital Z, and then it goes lowercase a to lowercase z, and the decimal number for a lowercase a is 97, and a decimal number for a lowercase z is 122. Now let's just stick with lowercase letters for right now. So we're talking about 97 to 122. So what good is that? Well, now we can generate, because we know how to get a minimum and maximum integer value. So what we can do is we can generate that value and we can stick it inside of a C string or inside of a string. So let's do C strings for right now. So what I'm going to do is I'm going to create a char C string called random C string, and let's make it 32 characters. And then down here, we're going to create a for loop. And I'm going to say for int I equals 0, I less than 32. And actually, we want the last character to be a \0. So let's make it less than 31, I plus plus. Okay, so we're going to populate that with a bunch of numbers. Now, it's going to be 97 through, oh, I forgot what it was. Thank goodness I left it. So 97 through 122. So let's put that in a comment so I don't have to go back and forth. So we're looking for 97 through 122. And those comments are difficult to read in dark mode, but I can see it, so we'll walk through it. Okay, so let's take our code right here that we did for minimum and maximum, and let's just copy it into our loop, and we'll be making changes. Okay. So now instead of minimum random value, I'm going to want to say 97. Instead of the maximum random value, I'm going to want to say 122. Let's say 123. And the minimum random value again will be 97. Now why 123? Because we want to be able to get the lowercase z. If we just say 122, we'll never get the lowercase z. All right, great. So we're not worried about negative or positive, so that's good. We're not going to output it. Well, just not yet. We're not going to output it yet. So what I'm going to do is I'm going to say, and what was the name of our random C string? So I'm going to copy and paste that. So I'm going to say random C string of I is equal to random int 1. And let's see how that works. That might not work, but let's take a look. And I'm going to say cout random C string. And let's see what we get. So what this is going to do is this is, well, actually, so this is going to generate 31 or 32 numbers. We're going to put it in the C string. We might want to do like 10 of these. So what I'm going to do is I'm going to create another loop. So we can generate 10 random strings. All right, so see if it's really, really working. All right, so let's go ahead and play this and let's see what we get. Well, this looks pretty darn good. So there you go. So we've got our random strings. Now you could also include the uppercase numbers. So one way of doing that would be to do a random 0 to 100. If it's less than 50, then subtract, and what would that be? You would want to subtract, let me see, if the number is a 97 and we want to get a capital A, you would subtract, it looks like 32. So let's go ahead and do that. That's kind of fun. So I'm going to go ahead and do the same thing as I did for integers. So I'm going to say random 3 equals random of 100. If random 3 is less than 50, I'm going to say random int 1 minus equals, and what was the number I said? It's 65 is a capital A, 97, that looks like that'd be 32, so we're going to subtract 32. So minus 32. And then let's see if we get capital letters in there. Well, looks like we do. We get capital letters. Now you could do the exact same thing with special characters. This could be you could write a little password program. So what you could do is, instead of just letters, upper and lowercase letters, you could also include numbers in the string. And so how would you do that? Well, the ASCII value of 0 is 48. The ASCII value of 9 is 57. So let's say in this question right here, if it's less than 25, you're going to subtract 32, so you get a capital letter. If it's greater than 25 and less, or it's greater or equal to 25 and less than 50, maybe you'll do a number. So you could really get sophisticated here on creating your own set of password, your own set of random characters, random everything. Pretty neat. The other thing that you could do is you could copy then that to a C string, or to a regular string, because it's already in C string form for C++. But in C++, C strings can be much easier to use if you're going to be doing one character at a time. Totally cool. Random numbers in C++. That's totally great. Now, if you want to learn how to do it in C, not C++, but C, take a look at my new playlist on C, and that will be coming relatively soon. So there's random numbers. Very, very useful. You can write those to a file. You can just put them in an array if you want. We did both negative and positive integers. We did both negative and positive floating points. Hope to see you at our next video.